So I'm going to be talking about, for anybody that was here the last couple of minutes, running 3D graphics in LabVIEW, as well as this can be used for embedding web interfaces directly in LabVIEW UIs. But this enables some kind of neat stuff that you typically don't see in LabVIEW, which of course means I'm interested in getting it to work. Yeah. Okay. So what we're going to talk about, this was a LabVIEW application. The rendering was not being done in LabVIEW. Um, this is kind of two pieces of software, one running nested inside of the other, and some WebSocket communication between them. So this was autonomous driving. I'm using a game engine to do the 3D and the physics simulation of the car driving. But all of the decisions of the steering and the throttle to apply is done in the LabVIEW code, and all of the simulated distance measurements for feeding that back to LabVIEW, so we can do fun stuff with it. I am doing this with the Godot game engine. This could be done with Unity. I don't think you can do it in Unreal 5, uh, but you could also just build web pages to make this kind of thing work. Um, Really all that's in use here is a web page that opens up WebSocket connection to the LabVIEW application, and it runs all of that internally. Made a pretty slick API for it. But yeah, so who am I? I'm Derrick. I am Illuminated G on VIPM, GitHub, and YouTube. I currently am a software architect at Blue Origin, at a test software team. I've worked on projects on everything from surgical tool end of line testing with computer vision analysis to full chassis helicopter sensor simulation, hardware in the loop labs, to most of my time was in oil and gas, working on high pressure, high temperature test systems. And I mean high pressure and mixed automation and manual control. It's always fun trying to get the system to not do dumb stuff while people still have the ability to click buttons and do stuff. Uh, s- Spent a brief time at NI as a technical support engineer. Got to work alongside Darren and Norm. That was pretty cool. And I spelunk all of the dark corners of LabVIEW that I can get my grubby fingers into. Um, so yeah, I've got a bunch of stuff open source on GitHub. I got a bunch of packages published on VIPM. Published a bunch of stuff to YouTube, as I said. Post on my shenanigans on LinkedIn. Most of the time, people are like, "What is this? Why?" Because it's fun. I think LabVIEW is fun. I'm trying to encourage more people to view LabVIEW as fun. We'll see how that goes. Hopefully, this year's Summer of LabVIEW challenges help with that even more. So I hinted a bit about what makes this work. So there is now the IG Godot server package on VIPM. This gives you a small handful of VIs that integrates a web server under the hood, makes all the WebSocket connections and everything work. And this just runs inside of a web browser. I am using Klein's WebView 2 package from VIPM. You could have this open up in an actual web browser and make that your primary interface and talk to a LabVIEW application. But on Windows, it's pretty slick. It is a .NET control, but can get this embedded right in a LabVIEW application. So this layer of the library is very small, specifically to hide the very extensive web server that I implemented in 100% pure G code. What this does not provide is any kind of specific protocol or messaging format for the communication with the web application. Um, for what I'll be showing off today, I'm using binary communications and sending actual encoded floating point values, integer stuff like that. You could use it for doing JSON messages as WebSocket payloads, any other kind of text format, whatever you implement the communication handling code. Yes. It's LabVIEW Wizard elsewhere. I figured here LabVIEW Goober was a good one. So this is Okay, that's a lie. I did add one more thing over the weekend, but this is every VI you would need to use this toolkit. So you got an initialization. You just have to tell it what port you want to use and where the web export of whatever web app you're running, where that lives on disk. Um, and so that's here on the left. You start the server. You can get the page URL if you wanted to embed that into Klein's WebView 2 X control, or if you wanted to trigger automatically opening it in a browser and do all of your primary UI stuff from the browser. And then there's functions for writing and reading payloads. Again, I'm doing everything as flattened binary strings. So I've got some utility VIs and I'm formatting everything so that it directly unflattens into a cluster, but can result in some pretty minimal amount of code to make this work. So what am I using this for? Well, that demo, that little app I was running at the beginning of the presentation, this is the entire code base of everything from the application and up. So anything that wasn't just a VIP package install to make this functionality available. So relatively small application for some hopefully engaging user interface interactions. But this is going to be used primarily for Summer of LabVIEW. That is a competition thing that Darren and I started when I was at NI. And it's a yearly competition, encourage experimentation and learning with LabVIEW, and trying to make it as engaging and as interesting as possible. One of the big pushes after the first 2 years is try and lower the barrier to entry. But my personal goal is to make it as interesting as possible. And this, with a little bit of game development I've done on the side in the past, this seems like a really great way to do that. Um, as you see this, if you have any more ideas for Summer of LabVIEW challenges that you think would be good candidates for this, I'd love to borrow some ideas. Want to keep growing the collection of challenges that are available and just make Summer of LabVIEW bigger and bigger every year. So the Summer of LabVIEW, I'm gonna have to revise that website. I will be officially kicking this off in May at NI Connect, where I'll be presenting about it with Darren. The right now I gotta revise the website and get some of the new stuff up there. Everything is available on VIPM. Actually, probably skip ahead and show that right now. I would like to close, please. So in VIPM, you can search Summer of LabVIEW, and there's Square Battle, which was the main one we did last year, um, and there's a maze one. This racing one will distribute as a VI package as well. They give you project templates. So talking about some of those hooks that Q was talking about in the previous presentation. These will give you. Uh, I have these installed, right? I don't have them installed on this machine right now. I can't show you. You'd get project templates that show up in here. That give you just about everything you need to get started. So what could you use it for? I'm obviously doing it for fun for now, and some other stuff. That's not public right now. But you could use this for anything that you would want to do with higher fidelity 3D and 2D graphics. You could do interactive visualization of dots. It's a game engine, so games are kind of the king of interactive things with extensive user interfaces. Things that LabVIEW are not great at are dynamic UIs. Things that web pages and games are very good at is being very dynamic. So you could offload some of the UI capabilities to a web browser that you embed in the application, and you could even mix and match if you want, or lean fully one way or the other, or like that one VI I showed for opening a URL in the default browser. You could make a browser the main user interface and launch that from a LabVIEW application. But you can do animations, simulations. This could be used for VR, AR type stuff. One of the awesome things about Godot is it does have all like the Godot. game engine editor is written with Godot, and it's got tooling for doing node-based editors. So I have no idea what this is on the right. It's Material Maker, presumably for generating textures to apply to models in game engines. Um, but it's got this kind of slick node-based editor, um, and so it's really up to you what you can do with it. So Godot, it's a pretty minimal game engine. When you install it, you don't even really install it necessarily. It's one executable, and it's the entire editor. Has all of the compilation tools and everything built into it. It does download some exporters and stuff to user profile directories. But it's got everything you need to make games, which means all the fancy interactivity you could more interactivity than you could ever ask for in a LabVIEW application. It does have its own programming language called GD script, Godot script. It is based extremely heavily on the Python syntax. You can do uh, um, what's the term for by default it's non-strictly typed, but you can give it all the type hinting, which lets it run faster. It also has C sharp available, but that's not available for these web exports. If you wanted to build an actual standalone application with a game engine as the UI for a LabVIEW backed application, you then have more options available. You could use regular TCP communications, but when you're running as a web page, WebSockets are the main means that are available. And Godot has lots of tutorials available online. So as stated, I'm using WebSockets. I've got a little bit of reusable code that I can plonk into any Godot project. And then it has event hooks called signals in Godot that I can then plug into any other project specific scripting that I'm setting up. So here you can see there's which one is this doing? So it's checking to see if it's connected. Once it does get connected, it can emit a connected signal, which if something was registered for that would be able to react to the connection being established. If this was a real application, like the racing one doesn't really care too much. But in a larger scale application that you could maybe actually enable some functionality, um, enable some things in the UI, update the UI to say that it's connected. Uh, if there's packets available, get a packet and emit that as a signal, so that other code, so my player controller code, in the case of this racing game, can handle that and knows how to decode that. Um, in Godot, there is a packed byte array class that allows you to do this kind of binary communication, and it's got a bunch of decode and encode functions available on it. Here we can see I'm doing some decoding of a U8, and I'm basically just doing everything so that I can work with clusters on the LabVIEW side and flattening and unflattening from strings. Um, LabVIEW is the oddball here. LabVIEW sticks with large endian, big endian, uh, even though the host order is usually little endian. Godot is little endian. So when you're using the flatten to string and unflatten from string, you just have to remember to set the little endian mode, which usually isn't needed if you're just doing LabVIEW to LabVIEW communications. But with this, that's basically the one gotcha. So this year's new Summer of LabVIEW challenge is called Formula G. This is the entire starting point of the application. This is all you have to add some code in. Unlike previous years where we've kind of kept some basic or demo implementations protected because we don't want people just copying the code and we want people to try and be as original as possible. But with something like Square Battle, that could be a pretty heavy lift, and you could spend months working on an entry. So this year, I think I've achieved my ultimate goal. Y'all can let me know how accurate that is. But this is the driving logic that was driving that code in the opening little bit of the presentation, and we'll be demoing this again. But the idea is your car has 5 measurements along the front of it, 5 measurements behind it to tell you how far walls are away, and then you get to build all of the driving logic yourself. It has perfectly accurate positioning and heading and speed and all of that. Real world AI cars wish they had that good of odometry and GPS positioning, but for this, we'll give you 100% accuracy. But that's it. So you get some ranges, you get your car info, and the whole point is to provide back what steering should it be, full left, full right, somewhere in between, and throttle from 0 to 100. And so you come up with those two numbers somehow, and you're literally off to the races. No classes, no um, complex stuff to get working. Um, Pretty simple this year. I kind of talked about this. Here's some more example communication code. So I've got an enumeration um, that I'm changing that to an I32, flattening that to the equivalent 4 bytes in little Endian format. I've got the 1 byte that signifies it's a set camera command. Um, and so in the WebSocket communication handler, it first decodes that message ID. It's going to see that in this case, it would have been the 6. So, of course, this is a different programming environment. I don't get to share type defs or enumerations or anything like that. But then decodes which index of camera should get used, and then call the method to change which camera in Godot to make the active one. And I'll show that off in a little bit. So yeah, let's look at the code. Yay, it's still running. So I do have two car controls here because I'm experimenting with some other driving logic. But basically, once this is distributed as a VIPM package, you're going to get a project that gets created that has these two VIs displayed. I'll just get rid of this one for now, and some instructions. So you can get some more details if you forget what you're supposed to do. Um, Cool thing is you can leave this car control VI open. So I could dynamically, while this is running, change some of the sensitivities, and this will probably hit a wall at some point, or maybe not. If I turn it up too much, yeah, there we go. It crashes. Can reset it. It does some stuff like draw the trace that it makes around the track, so we can see that it's pretty not repeatable back in this corner. So you could see maybe there's something I could handle about making it more consistent about how it's steering. Um, so you have this ability to leave this open, and if you do things as UI controls, tinker with values live. But of course, they were set to begin with where it should be. And again, this is the whole code. So I can come in here and all this is basically doing is steering away from the wall it's closest to, and just doing that constantly with a little gain factor applied to that. So can start off really simply. This is exactly what you'll see when this installs, and you'll get to go from there and try and make it go faster. So yeah, that's the LabVIEW bit. Um, there is a bunch of code that it pulls in that it just leaves in dependencies, which is not intended for anybody to work on. Build specification. Once you're satisfied with your submission, build this zip. That's what you would upload once the website's updated to handle this. Any questions so far? The So with the car, it's implemented with the Godot vehicle physics. Um, it's probably hard to tell from this. Oh yeah, the camera. I can go to an overhead view. So now we can see there the cars there about to go around that corner. These are the position where it's doing the distance estimation. I can see I've got some utility code that I included um, that you can visualize it here to see what's going on. Um, it will not really bounce. If it does flip over onto its back, it will try and roll over, but it's up to you to make sure it continues going in the correct direction. Still got to work out some of how I'm actually going to run this challenge. I'm thinking maybe something like complete 5 laps, take whatever the fastest lap time was within those 5 laps, just to give you a lap or two to get your speed up. And if you're going to do things like mapping or any kind of live training, you'd have the capability, and then try and have 3 laps to try and get a fast time. But yeah, I'm not sure if I want to go too much into detail. The This Summer of LabVIEW challenge isn't released. I'm just introducing it for now. Um, but did want to talk more about, the presentation is mostly focused on this Godot integration. So if anybody had any questions on that to start with, otherwise, if there are no questions about the Godot integration and again, oh yeah, I should probably show off Godot. So here's the actual, here's the map that was playing. I can play this in Godot. You go to project, you go to export. This is just a web build. It builds an HTML page that oh yeah, so it's just building an HTML page and some JavaScript and WebAssembly files that the server that's hidden underneath a couple of layers then runs on the application side. Um, oh, right. So there is a WebView 2 package on VIPM. This is what I'm currently using. I'm thinking I might eventually uh, pull in some of this functionality into the Godot wrapper itself. But if we look at the user interface for the application, this is an X control that just shows up as a string. So I'm passing the URL into it, and it is the WebView 2 is a .NET control, and it's basically the Edge web browser. So when this starts up, it why am I not going to the block diagram? Why is my control E not working? .NET. But it loads that up, and then under the hood, that X control does all the navigation that it needs to, and runs it. If I change the camera selection, I've got the way I've organized this is I've just got the second utility class for organizing the functionality specifically for talking to this game implementation. Um, so it just wraps that up, checks that it's valid, throws an error if it's not, and then sends the set camera message, which under the hood is so it's hiding a fair bit of interaction with the web server and how it handles the WebSocket connections and all of that. But sets it to binary, sends that payload along, and then the Godot engine in the game. So if it's the control car command, it decodes out those two floating point values for the steering and throttle, applies them on the car, the race car. So it has those input parameters, and then it's got some other parameters I can tweak on the game engine side for how much power, what its maximum steering is in radians, and then every iteration, it just applies um, that to the physics engine variables, and then the physics engine automatically handles that. Do I have the other demo here? This is a custom web server. So this is the IG HTTP server. That is fully implemented in G. It's cross-platform. It doesn't use any Windows-specific stuff, so it runs on RT. I've got it running on a Raspberry Pi using the Hobbyist Toolkit. I've got a little touchscreen display here. with some buttons on it, and I can use that to talk to the Raspberry Pi, which is running that web server and has RS-232 connections to my video switches. We run it on Rios at work, but this has a whole bunch of stuff. So if I go into HTTP, I've got HTTP server side handling stuff, parsing, request handling, all of that. And then there's a pretty extensive web server with, which I should probably, I just pull it up in here. And I am working on adding some new documentation to this, but um, got a whole processing flow. All of these angled blue square, or actually any of the blue shapes is where you can plug in custom code. A whole bunch of error handling. It's got built-in functionality for authentication if you wanted to implement some authentication. It does a whole bunch of web stuff, not just make files available to for funny little demos like this, but it also does funny little demos like this. It does not. I don't like the LabVIEW web services because those require hooking into things with globals. With this, you're specifically initializing the objects that do the request handling. So you can pass everything in with wires, no FGVs or named queues or anything. If we look at the Godot code, the Godot server code, so it initializes the web server with the specified port, initializes the request handler that can serve files from disk, um, registers a handler that there's some response headers that need to be set for the Godot web export to work properly because of some of the browser features it uses. Set up the WebSocket connection. Uh, anything going across the internet is going across the internet and the network. This is fast because it's loading from this. If I look at the project, this lives right across side it. So here's the HTML code it's loading. It's not going across the network. This is just how can you display and talk to that stuff from a LabVIEW application. I did last year at GDevCon. Um, I'd say probably just the best place to get started is the GitHub page. Sorry, Darren and Norm. I'm about to Splunk a bunch of LabVIEW code. Let's see if do I even have that project in here? Do. Got to open another version of LabVIEW to show off this um, other application I'm running, which I guess, let's see how well this shows up. So one of the applications I have on here is audio monitor. I don't know how well that's showing up from across there. Yeah, okay. You can kind of see that needle moving. Video switching. But this is talking to the web server. It's running on a different computer, and the audio software I'm running, you can only access it directly. So I have a web server running on my main desktop, which is providing those audio levels to this other application. Um, and I use Actor Framework in this. So this has um, it accepts if somebody makes a request to this path. What port am I using? 4663. What was that path? Audio summary. So it's just providing JSON back, um, using my promises to make an actor message request. So it's running a DLL session in the background, gets the answer back, formats that, flattens it to JSON, sends it back. So yeah, the nice thing is I didn't have to get that actor and keyword from a functional global. Um, I don't have to worry about name collisions or anything like that. And when you pair actor messaging with like a promises framework for getting responses back, it turns into a pretty nice little DLL session handler that you can poke at from other asynchronous code that isn't actors. Yeah, with this initialization, so the first thing is initialize the so I'm hiding the actors and keyword in an API class that hides that in keyword, gives me a statically callable VI that hides the actor messaging under the hood. But then, oh, so actually, the way I did this is there's a notion of services in this web server where if you implement that interface, you get to register yourself with the web server. And then that's why when it was handling the request, it just got to ask the web server, hey, give me this API service object as like a dependency injection kind of thing based on the type you're looking for. And it gave that back. So you can just pull that out, use it. Kind of hopping all over the place now and getting very unfocused. Yeah, like I said, Q, I wasn't gonna need a whole lot of time, um, unless there was a lot of questions. No, you're fine. I got through all of my content. I probably should have asked for a smaller time block, but initially when I was gonna talk about this, I hadn't made the IG yeah the IG Godot server package that cleaned this up a lot. I did this and that gave me a lot less to talk about because there was yes, squirrel. Uh, there was a bit more to talk about when all of this stuff had to be done explicitly for an application that wanted to use this. But I wrap this up because I foresee doing this a bunch now. Now that I have it, yeah. Let Darren tell you about me getting distracted with new projects every other week. Oh, just wait. Now I get to play around with external editors. I don't know. I've got other stuff I got to finish up first. Too many baubles. Um, so yeah, I guess a couple more things. I guess to wrap up the Godot and web UI part of it. Web pages are kind of everybody uses the web these days. They're highly dynamic. You can have stuff show up and go away. Things where like in LabVIEW, all of your buttons have to exist ahead of time. All of your controls have to exist ahead of time. Uh, you could write a web page, use some framework like React or Vue or Svelte, send a message to add a new button, add at this position. You can have all of the JavaScript code on the web UI side handle that. Uh, just starts to open up the what's possible with something that can be integrated in a LabVIEW application, at least on Windows. On Linux, where you don't have the .NET control that can be embedded in, I would probably do the entire UI in the game engine, and there are UI layers that can be added in, which I am super not familiar with. Uh, but they have menus and buttons and all sorts of fun stuff, tree views, rich text. So those, if you start looking into what's possible with Godot, it's really kind of a lot. Um, and yeah, if we do get a bunch of interest on people trying to use Linux desktop for Summer of LabVIEW entries, I would probably go that route. Um, so instead of having the reset button in the LabVIEW UI, I would put it in the Godot UI and have it send back the message that it was resetting instead of LabVIEW sending the reset message to Godot. But just one of those things that I think is neat. Maybe somebody else will. Maybe somebody will come up with more interesting use cases. All of the packages and everything are open source on GitHub. If you're interested in using any of them or have any questions or find any issues, the issues tab is always available. Okay. Jayanth wants to see my tooling. So if I make I'm going to create a new project for this. And then I make a new class. So it's the normal default class, but I can right click it, go down to IG tools, scaffold, and pick default. And now here is my starting folder layout. Let's say I have one where you don't like that. Maybe somebody else, like if this was at work, you might have folders like this. And I wanted that to be the default. Get a class set up the way you want it, scaffold, save as. And that's now saved and is now available. I make another class. So now blue is available. You can mix and match if you wanted some smaller incremental sets of folders. Um, it only applies what doesn't already exist. So if I run this again, it's going to be fine. If I get rid of one folder and run it again, it's just going to make that one folder. Um, Shush, Casey. You know why that's not happening. Casey has the what word would you use, Casey? Pleasure of working alongside me for the past. Well, what was that? August, July? When did y'all start? This is done unique experience. This is done as a secondary project provider. This is so like he was talking about in the last session. Secondary project providers allow you to add in um, additional functionality to existing items in the tree. So this is registered to activate anytime. I think this also does it with libraries. Yeah, doesn't make much sense to do some of this on a library, but it works with classes and libraries because classes are libraries. Um, Uh, it's open source on GitHub. If you find the package on VIPM, it's got the link to the repository. Nope, not that one. I want to keep track of that one. So where is it? There it is. Repository. There you go. You can knock yourself out. Yeah, you can limit it. I initially implemented it to be just classes, but I explicitly wanted to because I make folders and libraries a lot as well. It might be helpful to have different lists of templates for libraries versus classes, but most of the time it's much quicker to make them very quickly and easily and delete the ones I don't need. Um, Instead of having to go in, I'm gonna make a new virtual folder. I'm gonna name it. I gotta right click it, go into the access scope, set this. I hate doing that. It's fiddly. I'd rather just make the eight folders and then delete the ones I don't need because that's a lot quicker. Um, in reality, I don't use it on libraries that often, but I use it all the time on classes. Um, I'm trying to convince everybody at work to use this folder structure. They like this. They I don't know. I think once you get into maintenance mode for software, the ability to change access scope more easily is nice. Like everybody focuses on initial development a bunch. These are kind of patterns I've landed on um, because I wrote code that was I continually worked on code that was 8 years old at a previous job. So very much maintenance mode and less as much new development. If I'm killing time, show the relative path VIP. This is a really cool one. IG relative build paths. This by default in LabVIEW, when you have a build spec, so this destination, if it's within a folder of the project containing folder, it'll save into the project as a relative path. And you can click this help button, and it actually tells you. Oh, this one doesn't. Okay, let me make an executable build spec quick. Yeah, exactly. That's I've I'm only writing software for the first time once, and then spending a bunch of time refactoring and updating and making new stuff. So I have definitely landed on streamlining that process as much as possible. So here, if I click on help, does this tell me destinations? Somewhere in here, I forget what help that was that I found. Do you remember, Darren? Oh, is it just on somewhere in here? I wonder if it's in the newer help. Oh, is that in a 2022 help only? Maybe it wasn't in here before. Everybody used to always say that this saves relative anytime lav you can. Pretty much the only time that you couldn't is if you were crossing a drive letter. It turns out you can actually only go up one folder. So if you're trying to have a couple of projects next to each other and building into common paths, and you want that saved relatively, this toolkit, this package, install this package, and enables it. And you can see that here, there's 3 levels of ascending the folder structure. Yeah, and thanks to Darren for putting up with me thinking I had found what the issue was, and then not, and then thinking I'd found it again, and I kind of did. But then he finally pointed me in a better direction. But then I realized it's actually documented in the help, although I can't find that right now. So it's not going to change from NI. But I did find like a whole bunch of posts from 2016, where a whole bunch of very key NI R&D people were swearing up and down that it saves relatively whenever it can. Thanks for stopping in, Alan. Yeah, I mean, it's hard to call it a bug when it's documented. I think the bug is that everybody was getting told for years and years and years that it should have been done the other way. So, yeah, nope, only one folder. I just, for the life of me, cannot find that documentation at the moment. Maybe it's in 2022. Mm. This is why I disable online help. And if you're watching, I don't know if this just works better on the NI network. Everybody at my work, we turn on the offline help. I did not look up a .NET interop assembly. Okay, I for the life of me cannot find that right now. I guess I'll plug that. If you go to NI help preferences, turn off that checkbox and hit apply. This does take a little bit to open up the first time. Now that it's open, I can switch to somewhere else. Um, where's something I'm gonna get a help from? Look how quick that loads. If I turn online help back on, even though help is already open, guess what? It's got to load a new tab. And it's going to take just as long as it did the first time. What's that puppy? Um, there we go. So yeah, nice. Well, I've shown off the fast file format and how quick it opens. NI help preferences. I could have sworn that was the page I was just on. Waiting. Yeah, this is one of the pages I was just on. Where's the. Yes, Justin. Oh, I looked right at this and didn't even see it. If the absolute path specified is the project folder or the folder above, it'll say relatively. It is explicitly coded to only go up one level. Yes. Yeah. So you can see in 2020 when I opened up the help, it was still the old help. So I guess it's only a documented feature since the new help system was created. Yeah, sorry. There's two people specifically that keep saying use the online help. We can keep that up to date better. I can't bring myself to. I'll waste like a third of my day waiting for help because it's never the first page. Like at this point, I'm not looking for the thing on the first page I get to. I'm needing to like spelunk for some info, and that page to page navigation. Well, yeah, I get in 2020, it was still a bug, but now we're on the online help and it's properly documented. Probably gonna be the most rewatched part of this recording later on. People going to figure out what the name of that setting is. Where to get to it. So yeah, so again, would love to get some more ideas for more Summer of LabVIEW challenges. I love this kind of stuff. You get a nice sandbox to play in, but you get some pretty relatively low barrier to entry on the coding environment. Please, more ideas would be great. Um, would love to maybe someday Battleship gets updated to do this word search, but make it like all shiny and sound effects like Vampire Survivors. The guy that made um, Vampire Survivors used to work at casinos. Like he is in touch with game theory and what gets people addicted to stuff. Yeah, I like. Oh, I mean, another great use of this is like robotics visualizations, sensor visualizations. Um, I would love to get into. Um, I'll probably be talking about this a little bit more in the when I talk about CTI at NI Connect with Steve Watts. But starting to integrate some hardware I/O and robotics stuff with this kind of setup. Yeah, I really quickly glossed over what you can do with something like Godot. But Godot is used for not just games. I mean, it's just a really rich user interface engine that can do a bunch of 3D stuff, but it also has really extensive UI capabilities, really extensive 2D capabilities if you want to do sprite or image based graphics. Like I said, lots of tutorials. Um, if you just go on YouTube and do a search for Godot getting started, you'll get a bunch of ideas. It's interesting, Darren. All right, well, I think I'm gonna wrap it up. I have definitely pontificated long enough, and I think the pup is itching for another walk. Nice. Probably in like 2 weeks, I'll get the package published. Definitely need to get the website rocking. Casey will tell you. I am swamped. Haven't gotten to play as much with the fun side projects, but hopefully soon. TM. All right. Thanks everybody for stopping in. See you at the next session.